So I welcome you all and hello everyone. So I welcome you all, the second sem students, those who are studying under VTU, okay, for this playlist. Where in this playlist I'm going to cover all the 5 modules, okay, for the mathematics for EEE stream, for all the second sem students, those who have just entered the second sem, okay. So I hope that the first semester was good for you all, and my intention is that to provide you the best content required, because the second semester mathematics is not that easy, it's a bit tricky. So I have already created videos for your seniors, such as second year and third year students. I myself am a student which I'm studying under VTU, and I had covered this subject in my lower classes, second sem, and I thought that I have with my brief notes and my lectures and all, I'm going to explain you all the 5 modules in detail, okay. So if you are not understanding anything in your classes, so you could refer this channel, okay, and share it with your friends if possible, okay. Yeah, so this is the VTU Academy, this is the channel name. You can share it with your friends if you are interested. So we are going to cover all the 5 modules in detail, okay. So according to your syllabus, I don't know the latest scheme, but in our time it was module 1 was vector calculus, okay. So this is the second sem max only for EEE stream. So please listen to these classes very carefully, and please like this video if possible, okay. Let us start with the modules now. The first module which I am going to cover is module 1, vector calculus, okay. So this is the first module in your syllabus. In that we are having 2 chapters. One is vector differentiation and second chapter is related to vector integration, okay. Where in vector differentiation we are going to deal with the scalar vector and simple recalling all the vectors, then magnitude, unit vectors, then gradients and all the basics and all. We are just going to refresh it, okay, which you have studied in your lower classes such as second PU and all related to vector algebra. Those things we are just going to cover now, and bringing you a confidence to solve more complex problems in the upcoming classes, okay. Yeah, so this is the first video in this playlist. So let us start with let us recall with some important points which we have discussed before starting our first chapter, vector differentiation, okay. First is scalar. What is a scalar? Scalar, it is a quantity having only magnitude is called a scalar, okay. Scalar is something which has only magnitude. Then next is vector. Quantity which have both magnitude as well as direction is called a vector. So these things you might be knowing because you had already studied it in your PUC classes. Okay, this is the simple definition of the scalar, where it has only magnitude, whereas vector has both magnitude as well as direction. Next is position vector. What is a position vector? Let P be a point in a plane. In a plane, consider a point P, then OP, that is from the origin point or the center to the point at the plane. If you join that line is represented as a position vector, okay, in that plane. So this is the OP vector, which is a position vector, and it is said to be a position vector, and it is denoted by small letter r, okay. So this is the symbol of r, where it has a direction. Position vector is given by OP is equal to r is equal to x I cap plus y j cap plus z k cap of a point P of x y z, okay. So this is in the 3-dimensional plane, okay. Here the plane is 3-dimensional because we are having 3 values, that is x, y, z, okay, where this I cap, j cap and k cap are the position denoted. They are the unit vectors in the direction of x, y, z axis respectively, okay. So as I have told you, this is a 3-dimensional plane. In 3-dimensional plane, if you mark a point P, okay, so in that in order to represent that position vector, we give it as a vector r, and it is represented in that 3-dimensional plane like this, that is x I cap plus y j cap plus z k cap, okay, where I cap, j cap and k cap are the unit vectors. Next, let us recall about magnitude. What is a magnitude? Magnitude of a position vector, r vector. Magnitude symbol is represented like this. It is like a modulus. That is equal to the coefficients of the position vector, its square, okay, that is x square plus y square plus z square, the whole root, okay. So this is in this way we should be finding the magnitude of the position vector, where in this the coefficients are x, y, z, right. Its square, that is x square plus summation of its squares, x square plus y square plus z square, the whole root, okay. So this is the magnitude of our Next, let us see a unit vector in the direction of A, okay, where A would be any position vector again. So unit vector is represented as, since in the direction of here they had given this vector, so this is the symbol of a unit vector where we represent its letter along with the cap symbol, okay. So this is A cap, and unit vector is given as vector A itself divided by magnitude of its vector A, okay. So like that the unit vector is defined, that is A caps, that is unit vector, is equal to vector A divided by magnitude of vector A. So with one simple example they had given here, this is about unit vector. Next, let us see about dot product, okay. For that we need two vectors, one is A and B. I have represented it as A and B. If A is equal to A1 I cap plus A2 J cap plus A3 K cap, again this is in a three-dimensional plane since we are having I cap, J cap, K cap. And let us consider B is equal to B1 I cap plus B2 J cap plus B3 K cap, okay. So now dot product is represented as A vector dot B vector, okay, yeah, where dot product of A dot B is given as A1 B1, that is the multiplication of the first coefficients of corresponding to I cap. So in A and B, I cap terms, that is A1 into B1 plus, and I cap into I cap we neglected because it would be I cap, the I cap into I cap is I cap the whole square, that we can write as equal to 1, okay. The same unit vectors, if we multiply it, the product would be always 1, okay. And if we have the different vectors, for example if we multiply I cap and J cap, then what we would be getting, the answer we would be getting it as 0, okay. So A1 B1 I cap is 1. Then if we do multiply this term with this term, A1 I cap into B2 J cap, then we will be getting our answer 0, because A1 I cap into J cap is 0 since those are different vectors. So the product also would be 0. Again, if you multiply I cap and K cap, that is A1 I cap into B3 K cap. So A1 B3 into I cap into K cap, those two are different vectors. So the product would be 0. 0 into anything is 0 again. So you should be multiplying A1 B1 plus A2 B2 plus A3 B3. Okay, so this is the dot product of A dot B in the vector form. Okay, for same unit vectors the product is 1, for different unit vectors the product is 0, the dot product. Okay, so keep it in mind. Next let us discuss about cross product. Okay, these things I'm just recalling it, you have already studied it just to make you thorough. Okay, cross product A cross B is given in the form of a determinant. Okay, A cross B, again in the first column we should be writing all the unit vectors I cap, J cap, K cap. In the second column all the coefficients of A, A1, A2, A3. In the third column all the coefficients of B, B1, B2, B3. Then take its determinant. I hope you know how to take the determinant. Determinant is simple. Consider this and this. I should not be considering that. Consider this part. First multiply A2 into B3 minus B2 into A3 or A3 into B2. Okay, into I cap. Then this is plus minus plus. Hope you might be knowing. Next we should be putting minus. Then after putting minus, these two you should be neglecting. You should be considering this and this. So A1 into B3 minus A3 into B1 into J cap. Now next is plus again. These two you should not be considering. Now these two, A1 into B2 minus B1 into A2 K cap. Okay, so in this way you should be finding the cross product of A cross B. Now next is angle between two vectors A and B. Angle between two vectors is given by cos theta. It is represented as cos theta, and in order to find the angle between those two vectors, you should be doing cos theta is equal to A dot B divided by its separate magnitude. You should be multiplying, that is vector A dot vector B divided by magnitude of vector A into magnitude of vector B. Okay, and if you want to find the angle, so theta we could be writing it as cos inverse of the same thing, that is A dot B divided by magnitude of vector A into magnitude of vector B. Okay, so in this way you could be finding the angle between two vectors. So hope it is clear. Next let us see some more important concepts, then that is scalar and vector functions. Okay, what are the scalar and vector functions? If to every point xyz of a region R in space there corresponds a scalar which is represented as phi, of x, y, z. Phi of x, y, z is basically in a 3-dimensional plane. If you want to represent in a 2-dimensional plane, we can simply write phi of x, y. Okay. So in this module, we are representing the structures in 3-dimensional only. So it could be mostly everything are of 3 dimension. So here phi is called a scalar point function. Okay, this phi represents the scalar point function. It is called as a scalar point function. For example, let us consider one equation for phi, that is phi of x, y, z is equal to x square plus y square plus z square. That is, if to every point x, y, z of a region R in space, there corresponds a vector A of x, y, z, which consists of all the terms. Okay, hence A is called the vector point function. For example, vector A is given as in terms of the variables x, y, z, that is x, y, z I cap plus x square y j cap plus y z k cap. Okay, these are just the simple examples how to represent the scalar point and vector point functions. Okay, now we have two important operators if you want to remember. One is vector differential operator. It is also called as del. Okay. Well, what is its formula? Vector differential operator is given by del is equal to dou by dou x. Okay. This dou is the partial differentiation term, where in the whole equation you should be differentiating only with respect to one single variable. Okay. So that is called as a partial differentiation. So hope you might be knowing it. Del is given by del is equal to dou by dou x into I cap plus dou by dou y into, it is represented as dou. Okay, it is written like this. See it again, dou by dou y into j cap plus dou by dou z into k cap. Okay, so this is the formula for vector differential operator. Now the Laplacian operator, it is simply the square of the del, that is del square. It's termed as Laplacian operator. Del square is given by dou square by dou x square plus dou square by dou y square, that is the second order derivative, plus dou square by dou z square. Why? Because I cap, j cap, k cap goes, because if we do I cap the whole square, I have told you already, it is equal to 1. If you multiply, if you do the dot product of the same unit vectors, the product would be equal to 1, as I have told you here. Okay, so I cap into I cap is 1, j cap is 1, k cap is 1. So these three terms vanishes in case of a Laplacian operator. So hope it is clear. Now let us see one more important concept, that is related to gradient. Okay, gradient, this is very important while we solve the problems. Gradient, let phi, that is the scalar point function, phi of xyz, be a scalar point function, then the gradient of this phi is given as del into phi, that is del phi. Okay, so in this way gradient is represented, and the formula for gradient is given by del phi is equal to dou phi by dou x into I cap, that is dou by dou x into phi. For example, if we have an equation of phi, first what we should be doing is that phi we should be partially differentiating with respect to x into I cap plus dou phi by dou y into j cap plus dou phi by dou z into k cap. We should be separately partially differentiating first with respect to x, plus then we should be differentiating with respect to y, plus we should be differentiating phi with respect to z. Okay. So in this way, the gradient is given. This is the formula for gradient. Please note it down. So these are some of the very important concepts which I had recalled in order to make you thorough about the vector algebra, because those concepts only we are related to that we are going to solve the problems in a very complex manner in the upcoming sessions. Okay. So these were the very important things. So hope it is clear. So please note these down. So now I'm just going to solve you 2 to 3 example problems related to all these concepts in order to make you thorough about this module. Okay. So let us see with those problems and wind this session. Let us get to the problems now. So this is our one simple example problem. Let us try to solve this problem with what we have recalled till now. Okay. One problem is, they have given one problem. See this question here. If phi, that is the scalar point function, phi of xyz, that is it consists of the variables x, y and z, which I have already told you. So this is one equation given for phi here. If phi is equal to x square y plus y square z plus z square x, then we should be finding del phi and del square phi. Okay. So this del phi represents the gradient which I have already told you, and we have its formula as well. And what is this del square phi? Del square phi is simply whatever answer we get for del phi, right? It's a square. Okay. that is del square. Del square we can simply say that it is a Laplacian operator, so we should be doing the second order derivation. That is whatever answer we get of del phi, then its derivative we should be again partially differentiating with respect to x, y, z separately. Okay. Yeah, let us do this problem and try to get the answer. First, write the formula for gradient. So we know that gradient is given by del phi is equal to, what is gradient given by? Dou phi by dou x into I cap, right? Plus dou phi by dou y into j cap plus dou phi by dou z into k cap. So this is the formula, right, for gradient, as I've already discussed. Now we should be substituting, that is del phi is equal to, now they are asking to dou by dou x, that is partially differentiating this phi equation with respect to x only. Okay, this whole equation. So if you do this whole equation, differentiate partially with respect to x only. So if you consider this x square y, we know that if you want to differentiate only with respect to x, so y should be keeping constant as it is. Only we should be representing differentiating x. So differentiation of x square is 2x and y keep it as it is. Now in this term we don't have any x term. So okay. So if we don't have any x term, so what we should be doing is simply we should be not considering this all. Okay, this would be completely equal to 0. Now wherever x is there, that term we should be differentiating. So this is 0. Then now we are left with z square x. Now again we have x term, z square we should be keeping it as it is plus z square, and differentiation of x is its coefficient, that is 1. Differentiation of x is 1. So this is 2xy plus z square into I cap. So this, now what we have done, this we have partially differentiated only with respect to x, this whole phi term. Now we should be partially differentiating this with respect to y now, that is dou by dou y into phi. So now here where and all we have y terms, here we have and here we have, here we don't have. So this you don't consider, x square into y. Now what we should be doing, x square keep it as it is, differentiation of y with respect to y is 1, so x square plus again y square z, z you keep it as it is, and y, that is differentiation of y square, that is 2y, so 2y, x square plus 2zy into j cap plus, now the same thing with respect to z now, partially differentiating. Now where and all we have z term, we have one here and here, so this is not there. Now y square z, y square you keep it as it is, differentiation of z with respect to z is 1 plus z square x, x you keep it as it is, differentiation of z square is 2z, so 2zx into k cap. Okay, so this is our answer for del phi. Now they had told you to find the del square phi, that is the Laplacian operator. For that, what we should be doing, I've told you, whatever the del phi answer we got, we should be doing the second order derivative. Again we should be partially differentiating. That is, if in this term we partially differentiate this with respect to x now, what we would be getting here? Here we would be getting 2y, because the differentiation of x is 1 and z square is 0. Okay, and I cap into I cap is I cap the whole square, that is equal to 1, as I've already told you. So we are left with only 2y now, plus, now here in this term we should be partially differentiating now with respect to y. Okay, so x square, we don't have any y term, so this is 0, and 2zy, so differentiation of y is 1, so left is 2z, right? Now here also what we are having, with this we should be differentiating with respect to z, that is y square plus y square, we don't have any y z term here, so this is 0, and here we have one z term, so differentiation of z is 1, so we are left with 2x. Okay, so simply we can write del square phi is equal to, take 2 common, x plus y plus z. Okay, so these are our answers for del phi as well as del square phi. So hope it is clear. So let us see one more problem. So this is one more problem where what they had given is the scalar point function phi they had given. Okay, and also they have given the values of x, y and z, that is 1, minus 2, minus 1. Okay, so this is the value of x, y and z. Hope you might be knowing it. Again, they had told us to find the gradient del phi. Okay, so del phi, again let us substitute the formula and write it. The formula is dou phi by dou x into I cap plus dou phi by dou y j cap dou phi by dou z k cap. Okay, this is the formula. So del phi is equal to, first we should be partially differentiating this with respect to x. So here we have one x term, so here we don't have any x term, so only this, consider this part. The differentiation of x square is 2x, so we have 3 already, so 3 into 2 is 6 and 1 x and y. Okay, 6xy into I cap plus, again this whole term we should be differentiating with respect to y now partially. So in both the terms we have y, so here if we differentiate with respect to y, so y is 1, differentiation of y is 1 into 3x square, that is we are left with only 3x square minus y cube. The differentiation of y cube is 3, this degree you should be writing first, into the 1 degree you should be coming down, that is y square. Okay, hope you might be knowing it. So if we have like this, the cube term, so what we should be doing, this term you should be bringing down, cube, that is you should be writing the coefficient into y and 1 degree down. Okay, and again if you want to differentiate this, how we should be doing is the coefficient into the degree, that is 3 2s are 6 and again 1 degree down, that is y. Okay, like this you should be doing the partial differentiation. So here now the differentiation of y cube is 3y square into z square. Okay, j cap. Now with respect to z, that is here we don't have any z term, so here we have. So the answer what we should be writing is minus y cube as it is, and the differentiation of z square is 2z. Okay, so 2z y cube into k cap. Okay, so this is the answer of del phi, but it is not done. They had already given you the values of x, y and z. So in this equation substitute the values of x, y and z, that is del phi is equal to 6xy, that is 6 into x is 1 into y is minus 2 into I cap plus 3x square. So 3 into x square, that is 1 square. 3 into 1 is 3 minus 3y square z square. Y square is minus 2 the whole square, that is plus 4, minus 1 the whole square, that is plus 1. So 3 into 4 into 1, that is 12. Okay, j cap, then we have minus 2 and z into y cube, that is z is minus 1 and y cube, that is 1 minus 2 the whole cube. Minus 2 the whole cube is minus 2 into minus 2 into minus 2. So we have 3 terms minus 2, so minus minus plus, plus minus minus. So and 2 cube is equal to 8. Okay, into k cap. So what we are getting, 6 1s are 6, 6 2s are 12. We have minus time. So del phi is equal to minus 12 I cap. Then 3 minus 12 is minus 9 j cap. Then minus minus minus. So we are getting minus again. 8 2s are 16 into k cap. So this is our final answer of gradient. Okay, while we substitute the values of x, y and z. That is minus 12 I cap minus 9 j cap minus 16 k cap. Okay, so hope it is clear. These are the two important example problems just to make you clear about the concept of gradient and Laplacian operator del square. So that's all for this video, guys. So I have started this video with a very simple concept, so to make you just clear about the concept. So in the upcoming videos you are going to see some of the complex concepts related to vector calculus, because the syllabus is not so easy. So just to make you understand that, I am trying to solve these kind of problems. If you are interested in these kind of concepts in your future videos, please like this video and put your precious comments in the comment section, because it would be very valuable to us. Also share these kind of videos with your friends, neighbors, relatives, those who are studying in second sem under EEE stream. So that's all, guys. Let us see you in the next video. Please like this video. Thank you.